Okay, so listen. Today, we've got 2 days of solving systems of equations. Hey, we got 2 days of solving systems of equations. And really, both today and tomorrow, we're going to talk about the calculator way to do this. So the difference is in the type of equations, okay? Today, we're talking about equations that have 2 variables. Tomorrow, we'll talk about equations that have 3 variables, okay? Now, it's pretty straightforward, but if there's 2 variables, you have to have 2 equations to solve that system of equations. There's 3 variables, you have to have 3. So tomorrow we're actually going to be looking at some that have 3 variables. Go ahead, knock it out. You know there's a automatic window right there.
I didn't
Huh? Oh, solving system of equations? Maybe algebraically. No. Alright, so let's get started. First, if your equation is not written as y equals, you have to first make sure and get it in that form. So we're going to solve each equation for y, if needed. Sometimes it's not. Like if y'all look at 1a, they're both already in y equals form. So they're done. They're ready. Now, once we do that, then we're going to go to our calculator. We're going to go to y equals. We're going to plug one of those equations into y1. We're going to plug the other into y2. Now, just think logically. If I graph 2 equations on a coordinate plane, what do you think would be their solution? If I graph 2 equations on the same coordinate plane, what do you think would be or indicate their solution? Yeah, so that's exactly what we do. We look for the intersection. Now you're going to visually see the intersection, but we actually want to find the values or the ordered pairs, the x and y value of that intersection. And we do that using these buttons. You're going to go second, trace. Then you're going to look at number 5, intersect. And you're going to go as close to that point as you can. And you're going to push enter 3 times. The third one says guess, and that's what it'll do. It'll guess the intersection. And it'll give it to you as an x and a y, which is an ordered pair. So here's the deal. There are 2 different ways that they're going to ask these questions. For example, numbers 1, 2, and 3 here, it simply says solve each system of equations. And then it gives me 2 equations. These we will answer by giving the entire ordered pair. Okay? But if you go to the middle of this page, if the instructions say you have 2 functions, okay, given f of x and g of x, find when f of x equals g of x. Now think about it, guys. If I have 2 equations, f of x and g of x, what would I do to find where they're equal? Wouldn't I take their equations and set them equal? Well, if I did that, what would I end up solving for? I would solve for x, which is exactly the point I'm trying to make. When the instructions are named or explained in this way, you're still going to go through the same process, but you're only going to give your x value of that intersection as the answer. So the top ones you'll answer as an ordered pair. The bottom ones you'll answer as x equals. And then the x value of that ordered pair only. So the only difference is the way the question is asked. Okay? So let's go to our calculator. And what should be the first thing we do to our calculator? I would reset it. Okay? Well, after turning it on, I would reset it. Did somebody say turn it on? Yeah, I would turn it on for sure. And then go second plus 7, 1, 2, reset that thing. All right, so here we go. First one. And if you look at your equations, isn't y already alone? Yeah, y is already alone. So I'm going to go ahead and go type these straight into my calculator. Here we go. X squared plus 3x minus 5. And then in y2, and it really doesn't matter which one we put in which one, But in y2, I'm going to put x plus 3. I'm going to graph. And again, what am I looking for?
Intersection.
I'm looking at the intersection. And how many of them are there for this problem?
2.
There's 1, 2. 2 of them. So let's find the first one. Second trace, number 5. Second trace, number 5. And let's just scroll until we get pretty close to that intersection. You don't have to be right on it, but get pretty close to it so it knows that you're talking about that one. And then you push enter, enter, enter. And what is that first intersection?
-4, -1.
-4, -1. Now let's find the second one. Second trace, number 5. We're going to scroll over to that one instead. We've already found the other one. We need to scroll to this one. Get pretty close to it. Push enter, enter, enter. What's that intersection?
2, 5.
2, 5. So, my solution, here's what this means, guys. The x and y, the only x and y that these two equations have in common are -4, -1, and +2, +5. Okay? That's it. If I plug -4 right here, I would get -1 for y. If I plug -4 in these two places for x, I would get -1. Those are equal in that location. Same for 2. If I plug 2 in here, I would get 5. If I plug 2 into these, I would get 5. That's the location that they have in common. They're the only two. Okay? That's what we're finding when we solve a system of equations. The locations on a coordinate plane, so ordered pairs, that those two equations have in common. Okay? Sometimes it's multiple points, sometimes it's not. Sometimes they never intersect. Sometimes they intersect once. Sometimes they intersect twice. So let's move along. Now, B, a little different, isn't it? How's B a little different? Yeah, y is not alone. So let's start with this first one. What do I need to do to get y alone? All right, personally, when I subtract 8x, I like to put it in standard form. So I'm going to write y equals x squared minus 8x plus 28. If you didn't put it in standard form and you typed it in your calculator not in standard form, will it still graph it correctly? Yes. But I like to put them in order, so there it is. Y equals x squared minus 8x plus 28. What about the other side? Y is also not alone, right? It also has another little monkey wrench. What is it? Y is negative. So I actually like to just move it to the other side. How? I'm going to add y. So -8 plus y on the other side. And now I'm going to get y alone, which is now positive, which I like. And I'm going to get it alone by doing what? Adding 8. So 4x plus 8 equals y. So I've got y alone now in both of these equations. So what am I going to go do with them? I'm going to go graph them. So 4x plus 8. Doesn't matter which one I put first at all, but I got to type it in right. Plus 8. And then also x squared minus 8x plus 28. Graph. All right, what's wrong with this one?
Wait, can you go back? I got lost.
To what? My paper
Yeah, your
or?
paper.
Okay, yeah.
Oh, okay.
Good?
Yes.
You sure?
Yes.
Okay. So am I ready to go back to my graph?
Yes.
Okay. So when you graph this, what do you notice?
There's no intersection.
You can't see your intersections because you only see your line. You don't see the quadratic. So what can we do? We're going to zoom. So push zoom. And we're going to zoom out. Now, it hasn't zoomed out until you push enter. Now it's zoomed out. And sure enough, here it is. Look, here's my line going up. And here's my quadratic. So I know it's going to intersect somewhere around in here. Y'all see my cursor? And I also know it's going to intersect somewhere up in there. I don't have to zoom out anymore. Okay? I can get to this location because I only have to be close to the intersection. I don't have to be right on it. So here we go. Second trace, number 5. Let's move to this one. right here. Push enter, enter, enter. What's that first intersection?
216.
216. And then lastly, I'm going to do second trace number 5 one more time. And I'm just going to scroll up here until it's kind of gone off and push enter a couple times. One more, and there it is, 1048.
What was the first one?
216. 216. So there they are, 216 and 1048. Listen, even though I went off the map there a little bit, when I pushed enter, 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 and it's trying to find its intersection, it's not going to find some crazy point. It will find the intersection. Okay? You just got to get as close to it as you can. All right? Bless you again. All right, so any questions over that? I'm going to show you one more because we have to use another skill on this one with our calculator. So first of all, let's get y alone. On this one, again, y is negative, so I'm going to add it. So x equals 7 plus y. What do I need to do to get that y alone now? Subtract 7. So there it is. There's that one. Got to do the same thing here. I'm going to add y. Subtract 7. The equations are almost identical, except one's just x, so it's a line, and one's x squared, so it's a quadratic. Now, y equals, let's plug these in. I got x minus 7, and I've got x squared minus 7. Now let's graph it. Now this one's a little different. Remember, I just did what on the last problem? I zoomed way out. This one I need to zoom back in some. So you can either zoom in, number 2, or I always just push zoom standard. Now, when I zoom standard, I can't quite tell how many times this intersects. I mean, it either skirts it and only intersects it once, or it goes right through the edge and it intersects it twice. You can deal with that a couple of different ways. What I do is I zoom in. So I'm going to zoom too, but then I'm going to scroll down there closer to where it is so it zooms in on that area. Now I can definitively see how many times is it crossing each other. Yeah, definitely 2. So I'm going to second trace number 5, and then I'm going to find that first one. It's already there. Enter, enter, enter. So one of them is at 0, negative 7. And then I'm going to go second trace number 5, and I'm going to go over to this other point just across the way here, and I'm going to push enter, enter, enter one more time, and I get 1, negative 6. So my solutions to this system of equations is 0, negative 7, and 1, negative 6. Questions? Davis, are you raising your hand over there?
Oh no, it's just.
You're good? Okay, anybody else? So using zoom is sometimes helpful. Just don't forget, when you use zoom, it's going to stay on that window until you choose to either reset it, 2nd plus 712, or you can always go back to zoom standard, number 6. Zoom standard. Okay, now the next couple are really simple. It's just the questions are asked differently. And like I said a second ago, when they ask using these instructions, given f of x and g of x, find when f of x equals g of x, we're going to give x only. So we'll go through the same process. In fact, this is easier because when they write them in function forms, do we ever have to solve for y? No. They're ready to type in right off the bat. Or it's a graph like this. We'll get to that one in a second. So A. Y'all remember where to find ln? It's on that bot. Yeah, I heard it. Bottom left corner. ln. Here's the only trick to this problem. when you do ln in your calculator, it automatically gives you a parenthesis. But if you look back at your paper, is x minus 2 in parentheses? No. So what do I do to deal with that? If they automatically put a parenthesis, I can't erase that. What do I do to deal with that? Only put the x in parentheses. Okay? The minus 2 is not supposed to be in that parenthesis. Remember, guys, it's the difference between horizontal shift and vertical shift. That x minus 2 is not in parentheses, so this is indicating a vertical shift, not a horizontal shift. Y'all understand that? So close out your parenthesis and then put your minus 2. So just be careful the way you type it in cases like that. And then the other one's pretty straightforward. Alpha y equals, number 1, we got 1/2 x minus 3. I graph it. Again, I think this one's pretty easy to see. It crosses right here once and right here twice. So I'm going to find these same way, but what am I going to give as my answer? I'm going to type these the same way, but what am I going to put as my answer? I'm going to put my x value only. So second trace, number 5. I'm going to scroll as close to that point as possible and push enter 1, 2, 3 times. And what am I telling as my answer here? Yeah, 0.64. So x equals 0.64. Yeah, I did 2 earlier. What did I do wrong? Second trace. Did I type something in wrong? Let's see. X minus 3. Oh, no, x minus 2. Let me try that one more time. Second trace, number 5. And let's get close to it. Enter, enter, enter. I don't know why I got it wrong. Did I do something different?
You were too far up.
All right, so 0.46. See, that doesn't make sense to me though, because let me show you something. If I were to go, watch this. If I do it again, second trace, number 5, and I go up here, and watch, I'm gonna go way past it. I'm gonna go way past it, right? If I push enter, 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 it finds it. I don't understand what happened that time.
Maybe you moved it like before you pressed enter.
Maybe. I must have done something wrong. So, my 2 answers, guys, please stop. My 2 answers are x equals 0.46, and you could say x equals 5.36, or just put them both. X equals 0.46 and 5.36. Remember, in those situations, we're only stating the x value of those order pairs. Questions? All right, for letter B, does everybody remember where to find log base 2? Brayton, do you remember where to find log base 2? Because you didn't yesterday. It's in alpha window. So y'all can do that one if you want. I'm going to look at C, and then I'm going to be done, and you can use the rest of the time to do the homework, which is the back. This one. Again, this is under the instruction. Where is f of x? Guys, please listen to me. Stop talking. If you want to go ahead and do your homework, that's fine, but don't talk over when I'm talking. I'm still, in this case, looking at these 2 locations where these 2 graphs intersect. So this one right here, yep, is 1, -2. And this one right here is what? 4, 1. Those are still my ordered pairs where these intersect. But because the way this is stated, what do I care about? Just the x values. So I'm going to say that x equals 1 and x equals 4. Or x equals 1 and 4. I don't care if you put x twice or not. But those are the 2 places where these 2 equations have the same x value. So the only difference between these types of questions are the way you answer them. Okay? if you did B out in front of me, the answers for B were x equals negative 1.9, whoops, 0.9, and x equaled 2.26. So look, very simple. Your homework's on the back, and make a note that number 6 and number 9 are the only two that only have one answer. The rest of them have two, okay? If you look at your intersections, all of them have two except for number 6 and number 9. Number 6 only has one because it's a quadratic where the line just skirts right on the edge. So 1. And then number 9 is the type that has, I guess it's a it's an exponential one and a line, and that line goes almost right through the middle, and you'll never cross again. So number 6 and 9 have one solution, the rest have two. So you'll find two solutions, two intersections for all of those except for 6 and 9. All right, y'all got plenty of time to complete this in class with your calculator, because some of y'all don't have them to take home with you, so you can do it right now.
First one, I can't see.
You can't see?
No.
Why?
Do you have the answer for the first one, just so I can check the second?
Yeah.
Because it was a really big number, I didn't know.
I got it. Go.
15.
Boom. That's exactly right.
Just like 15 times.